Now, folks, excuse me. When you watch the video of the notes, whatever day you did it, okay, some people in my other class did it Thursday when we didn't have school because it was already on Google Classrooms, right? But no matter when you watch the notes, doesn't matter. But we talked, I gave you an everyday example of a limiting reagent, okay? That example was a case of water, and I had two little boxes of Kool-Aid packets, okay? Now, a case of water has how many individual bottles of water? 24 bottles of water. Each of my little boxes of Kool-Aid has how many packets? 8. If you're a Kool-Aid connoisseur like myself, it has 8. So, if I have 2 boxes, how many packets do I have? 16. So what am I going to run out of? Kool-Aid or water? Well, I'm going to run out of Kool-Aid, and you can specifically tell me how much water I have left, right? How much? 8, okay? Had some unique math going on, okay? 8 bottles of water left over, right? That's all limiting reactants are. That's it. What is limiting the equation and something is left over? Kool-Aid limits, the water is left over. Now, I'm not going to lie to you. It's a lot harder than that for you folks because it's tougher to see when I throw this in there. Now, if I read my example here, 40 grams of sodium bicarbonate combines with 6 grams of sulfuric acid. How many grams of sodium sulfate will be formed? Well, do you think that 40 grams reacts exactly with 6 grams of sulfuric acid? No. One of them is going to limit the reaction, and one of them is going to be left over more than likely. I don't think our chances of them being exactly the right proportions are going to be there. Okay? But the first thing we need to do to figure out our limiting reactant is we have to have a balanced chemical equation. Now, I can tell that sodium sulfate's going to be formed, okay? But I need to go through and get my balanced chemical equation. Sodium bicarbonate, NaHCO3. We've dealt with this. Anybody know what sodium bicarbonate is? Anybody want to take a guess? We used it the other day in the lab. Gumby got her. What is it? Baking soda. Sodium bicarbonate is baking soda. Combines with sulfuric acid to yield sodium sulfate. I've got to learn how to write smaller. So, here I have my reaction. What type of reaction is that? A double replacement reaction. Excellent. Now, look, is this reaction balanced? Okay, I've got my reaction. It's my skeleton equation. Is it balanced? No, because I can see my sodiums aren't together. Okay? I'm going to need to have a 2 here. When I do that, my sodiums match up, but my carbonates do not. Put a 2 there. Sodium's good. Carbonate's good. Sulfate's good. How about 4 hydrogen? 4 hydrogen, good. Balanced equation, right? Now, I have to determine which one of these is the limiting reagent. Now, it's the natural thing for everybody to look at this and say, well, the limiting reactant is going to be 6 grams of sulfuric acid because it's smaller. Do you think that's true? We can't just do that. That would be real nice, but we can't do that. We have to compare. And what I'm going to do is I'm going to do a mass-to-mass reaction, and I'm going to start. It doesn't matter where I start with, okay? Sam, you pick one of these. Which one do you want to start with? All right, he wants to start with sulfuric acid. So what I'm going to do is I'm going to take 6 grams of sulfuric acid, and I'm going to do a mass-to-mass into sodium bicarbonate. Now, can you people do mass-to-mass reactions? Absolutely. So I'm going to pause my recording, and I want you to mass-to-mass this reaction. All right, I gave you a little head start. Now I'm going to roll with my mass-to-mass with this particular one. So hopefully we match up here. So when I do my math for this particular one, I'm going to have my final label be grams of sodium hydrogen carbonate or sodium bicarbonate. And I came up with 23 point, if I round it to 3 sig figs, it's going to be 23.4, right? No? Oh, you know what? All right. You know why? Because we did it the other way that I did earlier today. You're right. That isn't going to work out that way. So let me do my math. We're going to make this Sam's fault because he picked the wrong one. No wonder everybody was looking at me like I was crazy. I know I'm crazy, but how about 10.3? That sound better? 10.3 grams of NaHCO3. All right. So after that just small little misstep there, what is this telling me? This tells me that if I have 6 grams of sulfuric acid, how much sodium bicarbonate do I need? 10.3 to react exactly. Do I have 10.3? I've got way more than that, right? What was the number I had? 40, right? So I've got almost 30 grams extra, correct? So what is my limiting reactant? What is my limiting reactant? Sulfuric acid, right? It's all used up. I've got leftover sodium bicarbonate. That's the hardest part right there. Can you see why sulfuric acid is my limiting reactant? Okay. Now, does that have anything to do with the problem? I'm not done yet, am I? I've just got to know which one I use to do my mass to get the sodium sulfate. So which one am I going to use? Sulfuric acid, because it limits it. What if I would use sodium bicarbonate? I would get way too big of a number, right? Because not all of that sodium bicarbonate was used up, was it? So, next step is I'm going to take my limiting reactant, which was 6 grams of H2SO4, and I'm going to go mass to sodium sulfate. So when I do so, get my little piece of paper. Once again, convert to moles. I use my molar ratio, which is 1 to 1, right? I use my molar ratio. And I convert this back into a mass. So my final answer is going to be in grams of Na2SO4. Let me see if I get this one right. Excuse me, 2 significant figures. I come up with 8.7 grams. So basically, all I'm doing is mass to mass, or mass to volume, or volume to volume. But before I can do that, I need to determine which of my reactants is used up first. All right? Now, I'm going to give you some time. What I would like for you to do is, before we start working this one, write this down and write the balanced chemical equation. And then we'll get to working this once you have that done. Now, I love seeing it, folks. I love seeing it because I am seeing a lot of people that do this. They say, okay, Na and H2O. I have sodium and I have water, and I see a lot of people grabbing at their help sheets. Okay? I like that. I like that, having that help sheet handy so you know, all right, what am I doing here? Well, looking at my help sheet, what type of reaction is this? Single replacement. This is a single replacement number 2. An active metal plus water gives me a metal hydroxide and hydrogen gas. Well, specifically, my metal hydroxide is sodium hydroxide and hydrogen gas. I like to see it, folks. You know what you're doing. You're pulling out that help sheet, you're getting a single replacement reaction. Now, is this reaction balanced? No. I think all I have to do, though, is, if I remember right, 2's 2, 2. 2 sodiums, good. 4 hydrogen, good. 2 good. Okay, now I'm balanced, correct? Now, does it matter which one you pick to go mass to mass? No, it does not. Okay? What do you want to start with? Maya, what one do you want to start with? Sodium, okay? Great. Let's start with sodium. I hope you don't screw me up like Sam did. All right. Let's start with sodium, and we had 35 grams of sodium, right? Yeah. 35 grams of sodium. And I'm going to do a mass to mass to what? To water, my reactants, right? My reactants. Well, I know that sodium has a molar mass of 22.98977 grams of sodium. It is 1 mole of sodium. So I've converted this from grams of sodium to mole. Now I'm going to use my molar ratio. I know that 2 mole of sodium react with 2 mole of water. So now I've converted that into mole of water. If I go back to mass of water, I know that 1 mole of water has a molar mass of 18.01528 grams of water. So now I'm going to have my answer in grams of water, correct? Let me make sure that, yeah, all right. She didn't mess me up. So I get 27.4 grams of water. So this tells me that if I have 35 grams of sodium, I need 27.4 grams of water. Do I have 27.4 grams of water? I have more than that, right? So what is limiting my reaction? Sodium. Okay? Now, what was I asked? How many liters of hydrogen gas will be given off at STP? That's important because if it's at STP, I can use what? My molar volume, right? So, I'm going to take 35.0 grams of sodium, and I'm going to do a mass to volume of hydrogen gas. To 2.98977 grams of sodium. And you'll notice, people, that a lot of this is repetitive, isn't it? That is right there. Now this step's going to be half because I know that 2 mole of sodium. What am I trying to go to? Hydrogen gas, right? How many mole of hydrogen gas? 1 in my balanced equation. So now I've converted that to moles of hydrogen gas. And then finally I need to take it back into, well, I'm not going to take it back into a mass. I'm going to take it to a volume. So when I come up with my answer, with all my cancellations, I'm going to get my final label to be liters of hydrogen gas. Is that what I wanted? Absolutely. So when I do my math, I'm going to come up with 17.1 liters. Final answer. What do you think? Would you agree with me the toughest part is which one of those is actually limiting the guy? Okay. Now, could I just guess? Yeah, but guess what? You're a 50-50, man. I wouldn't be guessing on my WebAssign if it were me. If it's you, maybe. All right? I don't know.